Okay, YouTube, in this video we're going to discuss how you find the domain of a function just by kind of looking at its rule. And these are kind of some basic examples. But how to define the domain, let's start with just what is the domain. So we say the domain. The domain of a function, so we say is the set. So it's a set of numbers, but we say the set of x values, and we're going to put it this way, or input values that have well-defined output values that have well-defined y values, or we call these, output values, outputs. So in other words, we say it's the set of all x values that when you plug them into a function, you actually get a y value back. What I'm here to tell you is that there are going to be certain instances when you plug in an x value and actually you don't get a y value back. And so what I want to do is I want to actually outline those two instances in this video. So we say first, we say if there exists any x values for which the denominator of an expression equals 0, that would be bad, of an expression equals 0, then they are not in the domain. Okay, so the important thing is to say here, I mean, like we're going to look at this function over here in just a minute, but we say f of x or y equals 4 over x plus 3. You can see how if you were to put in an x value of 0 right here, you would get 4 divided by 0 plus 3, which is undefined. Okay, so we would say that the x value 0 would not be in the domain because this is an x value that caused the denominator of an expression to equal 0. Okay, so the second possible instance is this: if there exist any x values for that, let's just put it this way, that cause the inside of an even indexed radical expression. I suppose we'll start on a new line to be negative, then they are not in the domain. Okay, so basically what we're saying is this: if you ever had an expression where we had, like, say, the square root of x, something like that, that would be an even indexed radical. What we could say is, very simply put, we could say the square root of, like, x, if this were equal to y, we would not want to be sticking negative numbers in for x because you would end up with something that comes out to be imaginary and not real. Okay, so the two possible instances that we're going to have to kind of keep our eyes open for, let me get these out of the way here. The two possible instances we're going to have to keep our eyes open for are these. Do we have any expressions where there's maybe like an x in the basement? Or do we have any expressions where maybe there's like, I don't know, there's like an x on the inside of an even indexed radical, even, okay? So when we look through these, we're actually I'm going to break down for you how you declare and write the domain, but also how you kind of break down these situations. So we say, looking at this first function here, we say f of x equals 4 over x plus 3. Now, my questions are these. Do we have any x's in a denominator anywhere? Or do we have any, like, an x on the inside of an even index radical? I notice that we have this x in the denominator right here. So here's what's going to happen. Whenever you have an x in the denominator, we are going to set, okay, let's put this this way. We say 1. Set the denominator equal to 0, solve for x. That's what we're going to do, okay? So in this first instance, we say x is in the denominator. If I set x equal to 0, then I can solve for x. Well, the nice thing here is that it's already solved for. We say x equals 0. So we'd say the solutions are values not in the domain, are values not in the domain, because remember, these are the values that cause the denominator to be 0. So we would say, since this is not in the domain, the way we're going to write our domain is this. We say the domain. We're going to use funky notation here. We're going to say x is an element of the set of real numbers. So this is a really fancy way of saying x is really all real numbers. And then what we're going to do is we're going to put a colon here. We're going to say such that x is not allowed to be 0. And the reason why is because that was the x value that caused the denominator to be equal to 0, which would be a bad thing. So really what we're saying is the domain is all numbers except for you can't use 0. Okay, so let's take a look at this second expression. We say g of x. And this actually says g of x equals 3 times x to the 1/2, if you can't read that, which is, by the way, 3 times the square root of x. Okay, so I do want to comment on this. This is an even indexed radical. So when you have an even indexed radical, so this was denom variables, a variable in the denominator. When you have an even indexed radical and there's an x on the inside, what we're going to do is this. We are going to set the inside of the radical greater than or equal to 0, and we are going to solve for x. Okay, we're going to say these x values are in the domain. Okay, and the reason why is because what we're doing is we're saying, let's take what's on the inside of this square root of an even indexed radical. Let's take this part right here, and what we'll do is we'll set it greater than or equal to 0, because I know that if what's on the inside of this is greater than or equal to 0, then it's actually going to give me real number answers. So we would say, let's take this right here. We're going to set it greater than or equal to 0, and actually I've already solved it, so it's solved. Okay, so we say that these are the x values that are in the domain here. So what we're going to write is this. We say the domain. We're going to get used to writing this here. We say it's x is in the set of real numbers, so x is any real number such that x has to be greater than or equal to 0, because if you were to try to plug in negative numbers in here, or something less than 0, negative numbers, you would get unreal answers. So this one's kind of hard to read here. This one says y equals 5 times x minus 4 to the negative 1. So what I'm going to do is I'm actually going to simplify this here, and what this would be instead is this. We'd have to move this x minus 4 to the basement. We get 5 over x minus 4 to the positive 1. But again, I'm noticing that I have an x in the basement here. So what we did before was we said, let's take this and let's set it equal to 0, and let's solve this for what would cause this to be 0. So if I add 4 to both sides here, I get this. I get x equals 4. So we say the domain of this, we say the domain is x is in the set of real numbers such that x is not allowed to be a positive 4. If it is, then you would get undefined in this expression. So moving right along, we say this is I of x. I of x is equal to 7 times x to the negative a half. So this is like a double whammy here. Now, here's what's going to happen. This x to the negative a half has to move downstairs. And I also notice that if I rewrite this, I get 7 over the square root of x. Now, I don't want to rationalize this, but what I do want to point out is we have both problems here. We have an x in the denominator, and we also have an x on the inside of this root. So what we're going to do is twofold here. We're going to take what's on the inside of this, and we are going to set it greater than or equal to 0 and solve for that right there. So we get this right here, but also this. If it were equal to 0, then you notice that if I plugged in a 0 here, I get the square root of 0, and it would also be 0 in the basement. That would be undefined. So I'd also have to set the square root of x equal to 0 and solve this. And if I squared both sides, you say x equals 0. So this would be bad here, but these would, what we say, are being good here. So what we are going to do is we're going to define this as this. We say the domain. We say that we want x to be a real number. So x is an element of the set of real numbers. But we say x is not allowed to be 0, and x has to be greater than 0. So we say that x is greater than 0. If we allow x to actually be equal to 0, you can see how that would cause problems here. So let's take a look at this one here. We say, okay, y equals 7 over x squared minus 4. Now this one is unique in that I have x's in the basement, but so what this means is we're going to have to set what's down here equal to 0 to find out what would cause this to be true. So if I add 4 to both sides, I get, the square root of 4. I get this. I get plus or minus 2, which is interesting. I get 2 answers. So I would say that the domain of this, I'm going to try to put this in purple here, the domain of this would be x is an element of the set of real numbers such that x is not allowed to be a positive or a negative 2. That would be the domain of this function. Last but not least, I'm going to stretch this one out over here. We say it's k of x is our last example. We say 5 over the square root of x plus 2. So now, here's what I can tell you. I cannot allow what's in here to be equal to 0 because that was x is in the basement and that would be undefined. And it also has to be greater than 0 because it can't be negative. So what we'll do is we'll take what's in here this time, and instead of setting it greater than or equal to 0, we'll just say greater than 0 and say, well, what x values would cause this to be true? We could subtract this and solve for x on both sides. We say, well, these are the x values that you want to use. You can see that if you plugged in negative 2 for x, you get negative 2 plus 2 is 0. And the square root of 0 is 0, and that'd be 5 divided by 0, which is undefined. So we say only x values bigger than negative 2 is all ever going to satisfy this here. So we say the domain. Finish this one off here. The domain. We say x is an element of the set of real numbers such that x has to be bigger than negative 2. And so that is how you will state your domain, and that is how you determine domain.